we're going to talk about, in section 1.2, domain and range. Now this is not going to be comprehensive, it's just going to kind of go through the bare bones. So in general, when you're looking at domain and range, domain is the possible inputs, often thought of as the x values. Whereas range is the possible outputs or y values for any given function. Now it turns out it could be any given relationship because technically it doesn't have to be a function to have a domain and a range, though usually we speak in terms of functions. One way to keep this sorted out, x comma y, alphabetical order. Domain, range, alphabetical order. See the similarities? Now, how we express these are as intervals. Let me give you an example. If I'm looking at the function f of x equals 2x plus 3. What are the possible inputs? Well, this is a linear function. I could put any number I wanted. Big negative, very small negative numbers, 0, large positive numbers. In fact, for the domain, we could say that the domain is from negative infinity to infinity, meaning there are no restrictions. Now, please note, open, as in this is not a coordinate, but this is open, meaning this is the same as saying that x is greater than negative infinity, but at the same time less than infinity. That's what this interval notation is. That's why you can see why we use that. It's easier to write. The range, or the outputs. Well, for any value I put in here, now one way to do this is to visualize the graph, right? So if I'm looking at 2x minus plus 3, sorry, it's going to look like that. So as I head this way, I can put in any x value. There's no breaks or anything in the graph. I'm going to get any possible y value. That's what the arrows are all about, heading either direction. So the range would also be negative infinity to infinity. So barring anything that might restrict the linear function, like maybe it represents something physical in the real world, like maybe x is time, in which case we probably wouldn't want to talk about negative, but there are cases where you might want to do that anyway. We are generally seeing that linear equations have this as a domain and range. Now, things to keep track of, as in sometimes we get graphs that look like this. So if we're looking at this, like maybe this is y equals x squared plus 4. What that tells us is that this point right here is 4 on the y-axis. Now, what does this mean? It means that, well, we can take any number and we can square it, right? There's no restrictions. 0, negative numbers, positive numbers, no problems, which means that the domain is any value, negative infinity to infinity. And the range would be, well, here's a problem. If you look at this, there's parts where this graph is not. Is it as low as 4 on the y? Yes, that is the lowest output is 4. Does it actually equal that value? Yes. So don't forget, that represents a, well, this is the same as going to be saying, we're going to say y is greater than or equal to 4, which means we're starting at 4, and how high are we going? Well, positive infinity, aka that away, right? Ad infinitum, right, into infinity. So that would be the range for that. So it's related to where the, in this case, minimum is. There are other situations where you might have a maximum, right? And that could tell you something. Or you could be looking at a function, let's say g of x, that is 2 to the x power. Remember exponentials? That would be a function. In that case, we're multiplying by 2 each time, so that's exponential growth, which means it has very small values. Then it crosses the x-axis, or sorry, y-axis at 1 and grows without bound, right? Now it turns out that 2 raised to positive or negative or 0 is possible, which means that the domain would be negative infinity to infinity But the range, if you look at this graph, now 2, if I raise to a negative exponent, remember a negative exponent like 2 to the negative fourth would be the same as 1 over 2 to the fourth. So as I put smaller and smaller negative numbers in, like negative 5, negative 6, I'm dividing by a larger and larger number. Now 1 divided by the largest number you can think of, let's say infinity, is going to be, well, still a number, right? It's still going to have something. It's going to be really small. So it turns out that we've got a boundary of 0 in the y values. In fact, it's never going to hit the axis in this particular case, but it's going to grow without bound. Notice the arrow, right? The end behavior of this graph is indicating that's going to go to positive infinity. One last situation. You may run across functions like good old r of x, which says that we're looking at 2 over x minus 3. Now, looking at this, you'd say, oh, okay, I can put x values in until I'm blue in the face, right? Except when I end up dividing by 0. So if I were to put 3 into this equation, r of 3, I'd get 2 over 3 minus 3, which is equal to 2 divided by 0, which we cannot do. No. So what does this mean? There is an x value that does not work, which means that we have a restriction to the domain. So we'd say that the domain could be from negative infinity all the way up to, but not including 3, and union 3 all the way up to positive infinity. What this is saying is, this is a fancy way of saying x cannot be equal to 3. And how do I know that? Well, when is x minus 3 equal to 0, right? You'll see these with rational functions a lot. Range. Now, if you're looking at this graph, basic rational function looks kind of like this. Now, this has been stretched and it's been shifted over. So what we're going to see is a graph that looks like this, kind of, such that this point right here is, 3. And it's going to kind of look like this. Okay, so what does that mean? Now, let's clean that up just a little bit here. There we go. So something like that. Now it's actually going to be a little bit closer to the axis. In fact, it's going to be right on top of the axis. So what this means is there's actually, if you think about it, a limit to what the, so there's actually no way to have x be equal to 3, right? As an asymptote, if you remember that term. But there's also no way to get 0. If I think about this, I could put in a number such that I'm taking 2 and dividing it by a very large number, but I'm never going to, just like in the exponential, get to 0. So in this case, the range also has a restriction, but it turns out to be one value that we cannot have. What is that one value? 0. Notice how in both cases, soft or curved, right? Parenthesis there, meaning we're not including that. So in this particular case, that would be the domain and range of this function. We'll be talking in more detail about this and you'll get a lot more practice with it as we move forward.